The universe has existed for so long that its age is beyond our comprehension, and it will continue to exist for much, much longer. But not forever or forever. And if the universe ends, what happens then? That's a question humans have been wondering about ever since they learned to think. And we're still looking for an answer to it. Scientists already have several plausible hypotheses for the death of the universe. It could run under several scenarios, and some of them are truly overwhelming. It is what the death of the universe will be that directly determines what comes after it. Could the expansion of the universe rip it apart? What would happen if the universe begins to contract? Was the Big Bang the only one? And will it happen again? Today, we will answer these and other questions. What will happen after the universe dies? Please give this video a thumbs up. Likes are not just numbers. They send a signal to the YouTube algorithms that our content is valuable to viewers. And don't forget to subscribe. The earliest theory of the origin of our world is the so-called stationary universe, or steady-state universe. And the word origin is rather conventional here, because there is no origin. Supporters of this theory assert that the universe not only has no beginning and no end in space, but it also has no beginning and no end in time. They say it always has been and always will be. It has always been and always will be in a state of stable equilibrium. Even ancient people could easily come up with such a theory, because it is quite difficult to realize that something so huge, majestic, and incomprehensible as the universe can once come to an end. However, scientific data soon showed that this theory is most likely wrong, because it became clear that irreversible processes occur in the universe. Logic suggests that if something can end, then everything can end. Indeed, further physicists found out that at a deeper level, all processes are irreversible and everything tends to destruction. It is called entropy. And again, we make a speculative assumption. If it is clear that everything tends to destruction, it means that there was a moment of creation in the past. In the 1910s and 1920s, the Big Bang theory was formulated and became widely recognized. It is now one of the most stable scientific theories, and it helps explain the nature and evolution of the universe. But, as it often happens, only partially. It is pointless to ask modern scientists the question, what was there before the Big Bang? And today, we do not have such a goal. We are trying to deal with the opposite and find out what the end of the universe will be like. And we already have at least some background to make assumptions about it. You've heard many times that the universe is expanding, and it's doing so at an accelerating rate. This is really true, and a strange scientific term appeared in the late 1990s, dark energy. It is the cause and driver of this expansion. We call it dark energy not because it's actually dark, but because we don't know anything about it. Obscure energy would be more appropriate, but we don't even know if it's energy at all. But it's a convenient patch for a hole in scientific knowledge, and we'll use it like everybody else. So, there is something in our universe that is causing it to expand, and it's even more amazing how it all works. Yes, galaxies and clusters are flying apart, moving further and further away from each other. But this happens because space itself is expanding, in all places at once. At any point in the universe, space is getting larger every moment, and this process is accelerating. And interestingly, all large objects are moving away from each other in all places at the same time. If you don't get it, here's a typical example with an ordinary balloon. If you draw small objects on it and then start inflating it, these objects will start moving away from each other all together at the same time. And this process has no center. If you imagine yourself on any planet in the universe, you will see that you are in the center of the universe, because everything is moving away from us in equal proportions. And wherever you move, from each of your new locations, you will see the same result. Everything is moving away from you in different directions, as if you were at the very center of the process. There is one very grim consequence of this, and it will lead to one of the ways in which the universe will perish. And you're about to find out what that catastrophic prediction is. What happens if we keep inflating our balloon? It will burst, obviously. And what happens if dark energy continues to, inflate the universe? Well, it surely won't burst, you would say. Well, it may. It really may burst. And there's a very convincing theory of the Big Rip proving it. Look, here's the thing. We know that the farther away points are from each other initially, the faster they move away from each other. At some point, this speed starts to exceed the speed of light. Just in case, let us remind you once again that there is no violation of the laws of physics here, as it is not objects moving at such speeds, but space itself is expanding so rapidly. So the point where one object moves away from the other with the expanding space faster than the speed of light is the point of no return. It's called the event horizon. Anything that crosses that barrier relative to us ceases to exist. Just imagine. First, the most distant galaxies and clusters will disappear from the sky. Then, the stars of the Milky Way will fade, one by one. And finally, our sun will take its turn. At first, this process will be imperceptible, but then the effects will become more and more noticeable. If some poor soul is unlucky enough to be around to see it, he or she will see the sun suddenly snapping from an invisible tie and flying away to nowhere, leaving the earth in total darkness and complete loneliness. But this is only the first part of the final scene. Further, the process will go even more rapidly. The event horizon will quickly reach the Earth.
Oh, Jesus! Oh my God!
It will be torn apart, and then, even faster, the invisible, insuperable boundary will already be the size of an atom. And in the end, all things will simply cease to exist in an instant. It's impossible to say what happens afterwards, because before and after are categories of time, and there will be no time after the Big Rip. Sure, it's a gloomy end that brings a heavy sense of hopelessness, but there is an equally likely alternative, much more optimistic. Today's observations show that space is expanding, and the rate of expansion is increasing. However, let us recall that we know nothing at all about the nature of dark energy. It may well have properties currently unknown to us that could reverse the expansion processes. So once again, just because space is expanding at an accelerated rate now doesn't mean that it always will. What happens to a balloon if you stop inflating it and leave it for a couple of days? It starts to deflate gradually. And here, oddly enough, everything can happen in a similar way, but with very different special effects. Yes, it's quite possible that the universe will sooner or later stop expanding and start compressing. This could happen if the total gravity generated by all the matter in the universe exceeds the force of its expansion. This scenario is known as the Big Crunch. In this case, the processes in the universe will run their course until its size is reduced by a factor of 5. Clusters of galaxies will unite into one supercluster, which in fact will fill the entire universe, much shrunken by that point. Thus, such processes as birth and death of stars and formation of planets will continue to occur inside galaxies. But that'll be up to a certain time. As the universe contracts, it will become denser and hotter. When the universe contracts by a factor of 20, its volume will be only 1% of its current volume, and all galaxies will merge into one. The temperature of the cosmic microwave background will be 274 degrees Kelvin by then, and will continue to rise. That means there will be no liquid water left in the universe. It simply won't be able to exist. And this would mean the end of existence for biological life as we know it. Further compression of space will cause the universe to heat up even more. The planets will melt. All matter will crumple into a huge cloud of boiling plasma. Then, atoms and subatomic particles will scatter, and eventually, the universe will collapse into a singularity like the one at its birth. And that's it? The death of the universe? Again, we don't know. We can only speculate and construct conceptual experiments. And such speculation has led physicists and cosmologists to a very optimistic theory. It is known as the Big Bounce theory. According to it, when the universe reaches a singularity after the Big Crunch, it will be reborn by another Big Bang, and the cycle will be repeated over and over again, presumably forever, as far as we can talk about eternity in the absence of time and space. And there's not even much to add here, because we see the consequences of at least one Big Bang all around us. Although, who knows what the next universe after the Big Bounce will be like? Maybe there will be different laws of physics. Not to put too fine a point on it. We don't know if there will be any physics there at all, or if something completely beyond our comprehension will be going on there. All the described scenarios are interesting, appealing, even funny at times. But there is one scenario that seems the most likely to scientists. And it is, as usual, the most boring, although very dramatic. This is the heat death of the universe. The point is that the universe may or may not expand further, but in any case, entropy is occurring in the universe. Everything collapses, energy is dissipating, and everything is moving into chaos anyway. And unless the previously considered scenarios happen, the universe will just slowly fade away. So how is that going to happen? There are 4 clearly defined epochs in cosmology, each associated with a particular phenomenon. We live in a so-called stelliferous era. There is a lot of interstellar gas in the parts of the universe around us. It serves as the raw material for star formation. New stars are born from this gas, and this process will continue until all the interstellar gas is depleted. The end of this epoch is expected to occur between 1 and 100 trillion years from now. By then, the Sun and the vast majority of other stars will have exhausted their nuclear fuel and become white dwarfs, neutron stars, or black holes. The next epoch is known as the Degenerate Era. There will be no more main sequence stars. Most of the matter in the universe will remain as white and brown dwarfs, and some will remain as neutron stars and black holes. It will take an enormous amount of time, about a duodecillion, or 10 to the power of 39 years, for all these objects to cool down. White dwarfs will gradually give up their heat in the form of radiation and turn into black dwarfs. As for brown dwarfs, they too will cool down. The thermonuclear reactions occurring on their interior at a sluggish rate will eventually cease completely. At this stage of the universe's evolution, the main processes will be the annihilation of dark matter and proton decay. The proton is the elementary particle from which atoms are built. It's the smallest brick of matter. It is considered one of the longest living elementary particles. Its lifespan is about 100 duodecillion, or 10 to the power of 41 years. Now, by the time this era ends, matter in the universe will look like a vast ocean of free-floating elementary particles, with the occasional neutron star or black holes among them. The next era is the black hole era. According to some theories, black holes will form clusters and eventually merge together to form one giant black hole. According to alternative theories, black holes will slowly evaporate before disappearing completely. Black hole evaporation is a quantum effect caused by so-called Hawking radiation. The smaller the black hole, the more intense its evaporation, which eventually strips the whole of all its matter and energy. This process is expected to continue for 10 to the power of 100 years, a number also called a googol. Anyway, eventually, there will be only lifeless space left in the universe. This space will contain only tiny fragments of the former world: photons, electrons, positrons, neutrinos, and quarks. Over an unimaginable amount of time, these tiny fragments will occasionally find each other in the dark, empty universe. The collision of electrons and positrons will cause them to annihilate. In such a state, the universe could exist virtually forever.